Morning. Today we are going to see thermal equilibrium, right? Before going into the definition, I will go through the analogy first. Let me take two glass bottles or glass beaker and we are filling the water with them and they are connected by a glass tube in between, right? One is having a higher level of water compared to the other. So what will happen? The water from the higher pressure zone move to the lower area. Until which time? Until they become equal in height. Right, this will happen to a certain period of time until they become equal. The same principle is applied to the equilibrium. How? We are having a hot water here. Let we have the temperature as T1, very hot. Then the next one is a cold water. The temperature is T2, right? At the temperature here, the kinetic energy of the molecules will be very fast and they are ready to leave the surface, right? So what will happen? They are ready to leave and move to the colder zone. Here also molecules will be moving, but they are very slow in the movement. So what will happen? Until certain period there will be a flow of energy between them, right? After certain period of time they both stop exchanging the heat, but there will be a flow of energy between them. The kinetic energy of the particle become uniform here, right? So there is no net transfer of heat. That is what is thermal equilibrium. The same principle we are applying to the thermometer. If your thermometer is been placed inside our mouth, our body is warmer, so the thermometer will rise in the temperature. The liquid expands and reaches a certain temperature until where it matches your body temperature. At that time there will be no transfer of heat, so that is our final temperature of the body. Right, the same principle. So we are applying the same principle to the hot coffee and the silver spoon, right? When you are swirling it, the heat from the coffee tips moves to the edges and move to the top area where we are holding the spoon. Until what time? Until they become equal to the room temperature. After that, the spoon will not be warmer and the coffee will be coming to the room temperature. Right, this is the principle applied to the thermal equilibrium. The formula applied is heat transfer. Heat is transferred between something. So Q is equal to mc delta T. Delta T is, here I said T1 and this is T2. The final temperature is TF. So the formula applied is M1 C1 T1 minus TF, M2 C2 TF minus T2. Right, here no loss is to the surrounding. Heat is not lost to the surrounding. If it is lost, you have to add Q loss. Right, that's a separate topic we will discuss. So these are the things you should remember for them. Same temperature, no movement of the charges, right? They will become equilibrium and there is no net transfer of heat flow.